let's get into binomials times binomials, which would be very, very, very important, especially getting prepared for next units. So, and again, this, now rather than just having a term multiplied by an expression, now we have an expression multiplied by expression. However, the rules of distributive properties still apply. I need to multiply the 5 times the x, 5 times the negative 3, and the 2x times the x, and the 2x times the negative 3. However, I will advise you that applying it this way is nothing wrong with it, but it's not really my preferred method. You guys might have also gone through another method, which we would call FOIL. And basically what FOIL typically does is it does the same thing as distributive property, but it just organizes it as multiplying your first terms, your outer, your inner, and your last. And what sometimes is nice about FOIL is even when you do the FOIL and you represent it like that, it kind of looks like a face. So you can call it a FOIL face. FOIL is not anything wrong with that as well. However, I prefer to use a different method. And the reason why I like to use a different method is because it gives you an understanding of what exactly multiplication of two terms represents. And if you guys look at a rectangle, to find the area of a rectangle, you're basically multiplying your length times width. So when we're multiplying two expressions or two terms, basically the product of multiplying two terms or expressions is providing you with the area, right? Does that make sense? So if I said 5 times 9, that's 45. That represents like a box with length is 4 and width is 9, and the area of 45. So if I'm multiplying these two expressions, the product is going to really represent the area, or the space inside the box. Now, since we have two terms in each expression, I'm going to set up 2 columns and 2 rows. And basically, all I do is I represent one up top, and I represent the other on the side. Now, what I like about this method is, one, we can expand it. So it doesn't matter if my expression has 2 terms, 3 terms, 4 terms, 5 terms, or 20 terms. You just need to create 20 rows. OK? So it's one that you can continually expand. Because if I said 20 terms, can you guys imagine like drawing those lines 20 times? It can just be a lot. And what also is nice about it is it organizes everything. So now all I'm simply going to do is find the area of each of these boxes. So if I say the length is x and the width is 2x, to find the area of this little box is 2x squared. The length of this box is x. The width of this box is 5. So that becomes a positive 5x. The length of this box is negative 3. Length of this box is 2x. So this becomes a negative 6x. The width of, or the length of this box is negative 3. The length of this one is 5. So this becomes a negative 15. What's also nice about this is when you guys apply distributive property or FOIL, you're writing down each of those answers outside, right? You're saying, OK, this equals that, this equals that. And then you got to combine like terms. What's nice about using the box method, when you have them in order, then your like terms are going to be on a diagonal, or kind of in a row. So now we can combine these, because when you're adding and subtracting like terms, or you're adding and subtracting monomials, as long as they have the same base to the same power, we can add them. So therefore, this becomes, my answer is 2x squared minus x minus 15. Does anybody need me to write that out, or are we good with that? Good?